Start numerical 7.1 of Electrodynamics chapter. Okay, so here you can see that we have a cylindrical resistor of cross-sectional area A, length L, is made from material of conductivity, and this is the conductivity of material, which is shown by this symbolic representation. So further you can see the cross-section need to not be circular. So this is the diagram. You can see this is not, but most the ends should be the rounded, the circular form. Okay, so what I do, assume that the small all the way same all the way down. Okay, so both ends are in the same cross-sectional area. So if we stimulate, the potential is constant, it means that the potential should be constant, okay, over this each end, and the potential difference which is denoted with V. So this constant potential which is denoted with V, so we have to find the current flows. So this is the direction of electric field, and we arrange this resistor in the direction of z-axis, and this is the length of this resistor. So whether you can see this is the formula for current density, which is equal to the product of conductivity of material into electric field, okay, which is the force per unit charge. Now you have to put the value of electric field, which is the voltage over distance. Okay, so you can say V is equals to ED, and we can write instead of DL also. So you have to arrange the formula and get the value of electric field. So now further you can see what's going on. After putting this J value in the formula for current, simple current formula, which is the product of charge, current density into area. So after putting this value, we will get this term. So now further you can see what happened, and that the area, the conductivity of material, and the length are constant. Okay, so you can see there the conductivity in this equation, the conductivity of material, area, and length are constants. Okay, so you have to write it down separately. So further you can see now these are the constant terms, which is exactly equals to the obvious resistivity. Okay, so these resistivity actually equals to this, the conductivity of material L over this A. Okay, and now first you have to put the value of conductivity, which is the reciprocal of resistivity. Okay, and further that, you know, these are the constants. Sorry, these these are the constants. So you have to put the value of this resistance. This is the value. These three values are actually the resistance. So after putting this term, as you know that this is the reciprocal of this term, so you have to put in the reciprocal form. Okay, so this is the current value, which is equals to the 1 over R into V. Okay, so this is all about, we have to find the current value, so this is the value. Thanks.